We tend to think of the solar system as a perfect, unchanging clockwork mechanism, but it isn't. It is dynamic, chaotic, and slowly breaking apart. Right now, our closest neighbor, the Moon, is stealing energy from the Earth and using it to escape. Did you know that in the distant future, total solar eclipses will be impossible? It's true. The Moon is physically drifting away from us, getting smaller in the sky with every passing year. Today, we are tracking the slow-motion breakup of the Earth-Moon relationship. When you look up at the Moon tonight, it looks exactly where it is supposed to be. It feels permanent. But if you could fast forward time, you would see it shrinking. The Moon is currently drifting away from Earth at a rate of about 3.8 centimeters per year. That might not sound like much. It is roughly the speed at which your fingernails grow. But over billions of years, those centimeters add up to a cosmic tragedy. Welcome to Space Facts. Let's measure the distance. Why is it leaving? The answer lies in the physics of our oceans. We know the Moon causes tides. As it orbits, its gravity pulls on Earth's water, creating a bulge. But here's the specific mechanism driving the drift. Earth spins much faster than the Moon orbits. A day is 24 hours. A lunar orbit is 27 days. Because Earth is spinning so rapidly, it drags that tidal bulge of water slightly ahead of the Moon's position. This creates a gravitational misalignment. That massive bulge of water, trillions of tons of ocean, pulls the Moon forward, acting like a gravitational tow rope. In the laws of orbital mechanics, when you add speed to an orbiting object, it doesn't just go faster, it spirals outward. So quite literally, the kinetic energy of Earth's spinning oceans is being transferred into the Moon's orbital energy, pushing it away, inch by inch, every single day. But energy cannot be created or destroyed, it has to be traded. This is the law of conservation of angular momentum. If the Moon is gaining energy to move away, Earth must be losing energy to pay for it. And we are. The friction of those massive oceans dragging against the seafloor is acting like a giant brake on the Earth's rotation. We are slowing down. This process is lengthening our days by about 1.7 milliseconds every century. We have physical proof of this in geological formations called tidal rhythmites. These are ancient sedimentary rocks that recorded the tides like tree rings. By studying rhythmites found in places like Utah, scientists discovered that 900 million years ago, a day on Earth was only 18 hours long. Going back even further to the Moon's formation, the Earth was spinning so violently that a day lasted only 6 hours. The Moon is literally stealing our spin to fuel its escape. If we rewind the clock 4.5 billion years, the Moon was terrifyingly close. It formed just outside the Roche limit, the point where Earth's gravity would have ripped it apart. At this distance, about 15 times closer than today, the Moon would have dominated the sky, glowing red with the heat of its own formation. The tides back then were apocalyptic. Because gravity follows the inverse square law, being 15 times closer meant the tidal forces were thousands of times stronger. These weren't just water tides, they were magma tides. The Moon's pull was so intense it physically bent the solid crust of the young Earth, creating waves of molten rock and constant volcanic activity. It was this violent, intimate mixing that likely churned the primordial chemical soup, helping to stabilize our climate and creating the perfect conditions for life to begin. We are only here because the Moon was once a monster in our sky. The most depressing consequence of this drift is the loss of a beautiful coincidence. Right now, the Moon is 400 times smaller than the Sun, but it is also 400 times closer. This geometry means they look the exact same size in the sky, allowing for total solar eclipses. But as the Moon moves away, it appears smaller. In about 600 million years, it will be too small to cover the sun completely, and total eclipses will vanish forever. But where does it end? Theoretically, the moon will keep moving away until the Earth slows down enough that a day on Earth is equal to a month on the moon. This would take about 50 billion years. At that point, the Earth would become tidally locked to the moon, just like Pluto is to Charon. One side of Earth would constantly face the moon, and the other side would never see it again. But this lonely final dance will likely never happen, because the sun is expected to expand into a red giant long before then, consuming both the Earth and the moon in fire. The moon is playing a long game. It won't leave us completely. Eventually, the sun will expand and consume both the Earth and the moon before they can fully separate. But it is a reminder that nothing in the universe is static. The night sky we see today is a snapshot of a moment that will never happen again. So the next time you see a solar eclipse, cherish it. You are watching a spectacle that future civilizations will never know. If this story of cosmic separation moved you, hit that like button. Subscribe to Space Facts for more truths about our shifting universe.